Hello juniors, and for this video we're going to be going over best practices for coding. The first thing we're going to be talking about is what is GitHub. So I prefaced GitHub a little bit in the release video, but to talk about it more, it hosts your source code projects in a variety of different programming languages and keeps tracks of the various changes made to every iteration. It also allows you to collaborate with other people on your code and keeps your programs organized so you can look back on them whenever you want. So GitHub is somewhat like Google Drive, but for programming. You can allow GitHub to access your computer and you can have it pull the code projects that you're working on online to the GitHub repository. And so it will hold that information for you so you can access that from different computers. Other people can also access it so that they can edit the code and also give suggestions. But another major way you can use it is for getting jobs. You can use it somewhat as a coding portfolio to show what you have done. So it's one of the largest repository hosting services. Last year, 2018, GitHub reported having over 28 million users, and GitHub is used for people and companies to access your program and can aid you in getting a job. So it's very professional to have a GitHub, and it's kind of normal for programmers to have one. So one of the things we'll be doing at Cohort is having a GitHub sign up. So we'll sign you up for GitHub and set you up with your username. We'll do that at Cohort. But when we're talking about GitHub and using it, we want to talk about best practices and what people look for in your GitHub programs. So you want to keep your indentations consistent. So if you look at this small little function I wrote right here, you can tell that these lines right here, these 4 lines, are inside of this function because of the indentation. And then you can also tell that this return statement is also inside of this function. So you can keep kind of track of everything because it's all indented correctly, and you can read it much better than if you had different types of indentations. Other tips we want to do is keep your comments concise and useful. So summarizing your code to help yourself remember and avoid from unnecessary repetition. So we'll go over here to some examples of this. A note about this, in your commenting code project that you just did, we wanted you to be very detailed in your programming because we wanted to know that you understood the programs and to know that you could read the lines and literally type out what they do. When you're commenting your projects for future endeavors and whatever you're doing, you don't want to have a lot of comments like this one right here. This line gets the country code. Then it asks if the country code is US. Then it displays the input for the state. I don't need to see all of that. What I would like to know is what this block of code does as a total, and it displays the state selection for the user. So then if I really wanted to understand it, I could read into these lines and read the code. But just from the comment, I can see the overall message of what it's trying to do and what the code is, the product of the code is supposed to do. I don't need every line to tell me what to do. So I know that's a little hypocritical of what we told you to do, but this is the best practice for doing this. If you need these comments for yourself, that's fine, but you got to remember that when you're uploading these for public use, you want to follow the best practices so that you're not hurting other people in your programs, because that's just extra reading that someone has to do and scrub through. So another thing you can do is group your code. So putting your code into blocks helps you and other people who are looking at your code read. This kind of goes back with the commenting thing, but if you have your code in blocks, you can kind of tell that, okay, this is a section right here, and this is a section, and this does something, so I can read the comment to see what that code does. But then this also does something, so I can read that to see what that does. So more best practices that you can think about is you want to limit the length of your lines of code. So you can keep your code organized by keeping each line to a maximum of 80 characters. Eclipse has this cool line right here that kind of makes it nice that you don't really want to pass that line. For our projects, we haven't been worried about that, but in future, this is something you want to think about because you don't want to have to scroll sideways to read. If you think back to when you were doing your HTML coding, it was very hard to go all the way to the right to kind of read what was happening at the end. It was annoying and it would take longer. So if we look at this example, we can kind of see, okay, I don't need, along with that, you just don't want to have it too long and it becomes confusing to read. But so we can go over an example of writing lines of code and how it should look. So if we go here, we shouldn't have all of this code in one line. This should be broken up into multiple lines. So we're sent from, add to, set subject, set body, and then send. We don't need all of those methods in one line. Another bad is when you're setting a variable and you just have a ton of stuff going off the end. That doesn't help me, but good is if you enter it so that you can see, okay, this variable is from this comma or this quotation to this quotation, and everything inside of here is what's supposed to be inside of that variable. So it kind of makes it easier and you can read the whole thing without having to scroll all the way to the side. You also want to keep your code simple, and then also simplifying your code helps you limit the amount of lines you use, and it also helps for other people while viewing your code, and it also helps you in the debugging process. If you don't have to go through as many lines of code, then you won't have to debug as many lines of code. Kind of works like that. So now let's talk about why this is all important. Why are we talking about best practices? These practices are important because it keeps your code concise and consistent throughout. Those two things are key when programming because it shows that you can program in a simple yet organized manner. These are the skills and practices that programmers are looking for and will use to evaluate your programs. So to kind of summarize that, you want consistency and conciseness. And programmers will be looking through that in every program that you do. And the reason they look for that is so that when somebody else has to come and work on your program, so say you're working for a big company that you're managing their website database. If you're managing all that data, you're going to have your own way of organizing it, but you need to have it commented and easily readable so that other people can come in and read it and then say, okay, this is what they were doing here. This is how I can repair this. Or if it stops working, they can debug it as well. Or if it can't handle some certain exception, then you can build in exceptions without having to remake your whole program. So by having these best practices, you can really just edit your programs better, and other people can edit them as well. So now that we're done talking about best practices, I want to talk a little bit about programming strategies. So there are many ways you can start and execute different programs. So far, we've used the objectives, algorithms, pseudocode, and functioning to build our programs. So these are strategies that we very highly recommend, and they're highly recommended by professional coders. But you can also take liberty in what you will do to help your process of coding. So if you really notice that writing the algorithm or writing the objective doesn't help you, then don't do that for your professional coding. But for our class intensive purposes, we expect you to do all of these things. So most of the stuff we've done so far, we have like fed to you. So you could still do that stuff, but we expect you to still do that stuff for our course, but you don't have to in your own personal programming. So the objectives, algorithms, and pseudocodes are one of the ideas we fed you. So this is the process / strategy that most programmers use. It helps you build the code before jumping in and actually coding. For the projects we do, you may feel like it isn't necessary, but when you start programming stuff that's like multi-moduled and has complex systems attached to it, it will help. So the reason you want objectives is so that you can know, okay, this is what I'm doing with my code. This is what this is supposed to do, and I understand what I'm doing. The algorithm is built so that you can then break that down into steps. So kind of how you can make a step-by-step list for instructions to cooking. You can do the same for coding, and then you can code it. And then pseudocode is kind of translating it into whatever language you're using. So the great part about this is if you have these two steps done, when you're going to build another program, say you built a program for Windows, but you also want people in Mac to be able to use it. You're going to have to code it in a different language or somehow change it. So as long as you have the objectives and algorithms, all you have to do differently is make it in a different language. And that's as similar to how if you had a sentence that you wanted to write in another language, all you have to do is put it into Google and translate to a new language. All you have to do is put it into a new program and translate it into the new language. So it makes it much better to do this step because then you don't have to redo the whole program every time you want to use it. So the other strategy we've been using is functioning, or the act of using functions. So we do this to reuse repetitive code. So if I wanted to have something print out someone's name 100 times, I could just make a function that does that and repeats it 100 times. And if I'm using that multiple times throughout my program, instead of copying that while loop over and over and over, I can just make a function that anytime I want it to do that, I call back to that function. This is also a pretty unanimous thing used by programmers, but it's still a way of thinking about code. You don't have to do it, but if you didn't use this strategy, then our programs would be a lot longer, and some things wouldn't even be possible. So things like when you get into further programming, you have to use recurring functions where you use a function to call itself and keep going down and down and down. So if we go back up to our example of our indentation, the point of this function is to get the number n down to 1. So it just keeps going through and calling the same function until it's 1. Because at some point you input a number, and if it's 1, then it returns it. Otherwise, it does n minus 1. And it keeps going down minus 1, minus 1, minus 1 until it equals 1. So that's something you can use or utilize by using functions. If you don't use functions, then you're going to have a hard time doing that. So the last strategy we're going to talk about is how we decide to debug. So debugging is the action of finding bugs or problems in the code. So the best strategy is to complete small sections of code and then run it And then if there's problems in the code, you can debug it and in that section and move on. So then that makes sure that as you're going through your program, all the code that you've written beforehand is most definitely working. And then you know the problems are coming in with the new code that you're adding. So then there's less debugging to do. So that's all I have for this video. Please, again, just add a couple of notes from this to your cheat sheet, and then submit your cheat sheet on Canvas once you've done all of the additions that we've asked. And I'll see you later, juniors.